Hey, fellow mathers. Before we get into this episode, we want to share with you how you can get access to free content, professional learning that will keep your students engaged and doing the math that matters. Get ready to go to this link, mathisfigureoutable.com/challenge.
That's right. Registration is open for the free Math is Figureoutable Challenge that's starting May 15th and runs to the 17th at 7 p.m. Central. We're going to have 3 nights jam packed with learning and routines that you can take straight to your classroom.
In these challenges, we have a great time. We do some math, talk about classroom experiences, give away super cool bonuses and prizes. You won't just walk away with routines that are naturally engaging and encourage your students to think mathematically. You'll also have a chance to win over 6K worth in prizes, including a few virtual PD sessions for your school. I'll be joined by my wonderful co-host Kim and special guest Jenna Labe.
You can register at mathisfigureoutable.com/challenge for a fantastic learning experience. That's mathisfigureoutable.com/challenge. Now on to the show.
Hey, fellow mathematicians, welcome to the podcast where math is figure-outable. I'm Pam Harris.
And I'm Kim Montague.
And you found a place where math is not about memorizing and mimicking, where you're waiting to be told or shown what to do, but it can be about making sense of problems, noticing patterns, and reasoning using mathematical relationships. We can mentor students to think and reason like mathematicians. Not only are algorithms really not helpful in teaching mathematics, but when we rotely repeat steps, that actually keeps students from being the mathematicians they can be. All right, Kim, I got the super coolest email the other day that I wanted to share with you.
Okay.
A little longer than some of the things that we read on, but I think you'll appreciate it. So from Heather, she said, first of all, Pam Harris, as a dual credit and AP math instructor / department head / instructional coach / math lead for our district / UIL number sense coach. Oh, and then in parentheses, and academic coordinator.
She's busy.
Yeah, wears a few hats. I have only just recently discovered your existence. And I mean, this is a sincere compliment. I think you are my spirit animal. I thought that was so cute. I was like, okay. A couple of the teachers I've been working with at the Comanche Elementary are huge fans of yours and have been working to implement your strategies to build a stronger conceptual understanding of number reasoning in their students. Their efforts were impressive to me, and so I've begun listening to some of your podcasts. Well, thanks for listening, Heather. So far, I've loved everything I've heard you say. I've been so excited to find someone who believes all the things that I do, but has done the hard work and taken the time to make it concise and present it to others to have an impact beyond your own classroom or your own district.
That's great.
Quote.
That's so great.
So Heather, thanks. I appreciate that. And it is exactly kind of what I've tried to do is like bring all this stuff together that many of us are kind of playing with and thinking about, but putting it in a concise, consistent message.
Yeah.
And then doing my best to get it out to the world. Yeah. So if I may, thank you to Jennifer and Anne, who are the two teachers in her district who have been spreading all of the wonderfulness. Thank you so much for A, getting it going in your own brains, and B, getting it going in your own classrooms, and C, spreading it to those that you work with like Heather. So thank you very much for that.
Yeah. I mean, that's what we are hoping that lots of people do, right? Share the message and talk to their leaders and their coaches and their teammates to just keep this movement going.
Yeah, y'all, let's really change the world. I mean,
Yeah.
I'm still a little bitter that I could have actually understood all that stuff I wrote memorized.
Yeah.
Let's catch kids earlier. Let's catch people as early as we can and help
Yes.
that go.
Yeah.
Hey, so Kim, working off of last week's episode, y'all, if you teach younger students, hang with us today because you're going to be able to enter and do this just like last week's. If you did it with us, at least the first majority of last week's podcast should have made a lot of sense. Same thing with this one. We might go a little algebraic at the end, a little higher. What I mean by that, we might assume a little prior knowledge, but not till the end. So hang with us. I think you're going to have a good time, especially if you liked what we did last week. It's kind of fun.
Yeah.
All right. So Kim, last week you gave me some ages. You gave me some famous people, and then I guessed how old they were.
Yep.
This week, we're going to do something similar, but I'm going to give you a location, and
Okay.
you're going to guess how the average temperature in that location in July and the average temperature. Hang with me.
Oh, gosh. Okay.
Maybe I should tell listeners, Kim and I don't really talk about weather. Like
No,
some people are weather people. My husband's a weather guy. I don't know if he's going to listen to this podcast, but he likes to talk about the weather. When we first got together, I was like, are we really talking about the weather here? Because to me, it's like, I don't know, inconsequential. I don't care. Now, he says that's because I grew up in a place that didn't have weather.
Mm,
Which, I mean, maybe there's not a lot of natural disasters in Boise, Idaho. So you don't
no.
really, I don't know, it has nice 4 seasons. Things are consistent. Things don't change on a dime really fast. Like
Yeah.
you pretty much can, if today's today, tomorrow's going to be tomorrow, and it's going to gradually turn into the next season kind of thing. So maybe that's true. But anyway, Kim and I don't usually talk about weather. We're going to talk about weather today. Here we go.
Okay.
So I'm going to give you a place. You're going to guess the average
Oh,
temperature in July.
jeez.
I guess I should have asked you why you were laughing. I'm assuming because we're
Well, I
not
mean,
weather
it's just
people.
hot. All I ever say is it's hot, or maybe it's humid.
Oh,
I
that's
have no
true.
idea what the
Yeah.
numbers are. Okay.
Because we live in Texas, so it's
Right
pretty
now
much
it's
hot.
106.
It's like hot and not so hot. It's kind of,
Yeah.
yeah.
Okay.
Okay. Anyway, so I'm going to ask you places. You're going to tell me their July temperature and their December temperature. Okay. Kind of
Okay.
their average. I know. Just it'll be fine. We'll do it together. Maybe this is how other people feel when we do math, Kim.
Maybe.
When I
Well,
ask you weather
I'm fine with
questions.
not knowing. It's okay.
All right, Kim. We live near Austin, Texas, and so I'm actually going to ask you how hot. Oh, and this is going to be a little tough. I'm going to actually ask you in Celsius,
Oh,
centigrade.
I have no idea.
Hmm.
Holy cow.
How
Okay.
are we going to do this?
Can I tell you in Fahrenheit and then you tell me in Celsius?
Yeah, we might have to do that. I'm not the quickest converter, but yes, we can do that together. Why didn't I think of that before? All right, so y'all, this is sometimes how things go. You plan things. I knew I was going to do it, and I just didn't even think about. I know someone's out there going, Pam, you should be able to do this mentally. Sure, when you're not live
I
on a
don't
podcast, you
even
do
know
it.
the conversion.
The conversion, you know,
Is that horrible?
that's
No, I have
okay.
no idea.
No, but I can't spell Fahrenheit right now. There, I found it. All right. The conversion has everything to do with getting rid of the 32 degrees. You know how
Okay.
32 degrees in Fahrenheit is equal
Zero.
to
Yeah.
0 in Celsius?
Yes, I
So
do
you sort
know.
of get rid of that 32 degrees, and then you multiply by this fraction of 5 nights. Like, yeah, go figure. Who knows
Okay.
why? Okay.
Right. I'm
So
going to tell you Fahrenheit and let you deal with it.
I'll do the conversion. Okay.
Okay.
So, Kim, what do you think the temperature in Austin in July is about?
98.
You think the average might be about 98, and that would be about 36.
Okay.
And it's actually about 35 degrees. So right on, spot on.
Pretty close. All right.
Cool. How about in December? What do you think the average in December is in Austin?
I'm going to go like 45.
You think it might be 45, which is, I don't know, is that cold for other people? What, yeah. So it's actually not that. It's so 45 is equivalent to 7 degrees Celsius. It's actually about 16 degrees Celsius. So 16
Way
degrees
warmer.
Celsius is
Oh, I
about
was
60.
thinking like
It's about 60.
February. Yeah. I always think it should be December because that's like Christmas.
Christmas
for
should be the
us.
coldest month.
Yeah, it does, but it's February. February is
Yeah, it's
probably
like
more like
I think
45.
the end of January, February is more like
Yeah. We
Yeah,
were
cool.
just talking about this. Okay. Or I was with somebody else. Okay, so it's more like in the 60s?
60. It's exact 60. You guess 16, which is 60 degrees. Yeah.
Okay.
Fahrenheit.
All
Okay,
right.
so everybody, we're just going to say that Austin, Texas has an average temperature in July of 35 and in December of 16. So if I were to plot those as ordered pairs, Kim, where would they be? Where would the point, not they, but the point 35, 16, where would that be? Just because we can't like do it.
What do you mean where? Like in the
like just pretend you were graphing it. Talk out loud.
I would start at 0, 0. I'd go over 35.
And
I go up 16. So what do you mean where?
Well, so that's where it'd be. It'd be over 35 up 16.
Okay.
And so it's in the first quadrant.
Yes, quadrant 1.
That upper right hand quadrant, and we call that quadrant 1. Okay.
Yep. Okay.
Cool. Detroit, Michigan. You got any idea of is Detroit, Michigan warmer or colder than Austin in July? In July.
Colder? Well, I think it's going to be colder always than Austin.
It is colder, and it's about 7 degrees colder in July. So it's about 28 degrees in Detroit in July. Do you think it's warmer or colder in December?
Colder.
It's way colder.
Yeah.
The average temperature for Detroit, Michigan in December is 1 Celsius. So that's what, 33 degrees ish? Yeah.
Mm-hmm.
So right around freezing. I mean, so that's not actually, it's not below freezing. To
No.
be clear, I lived near Detroit, Michigan for 4 years. We had a cold day. We had multiple cold days, but the first time we had a cold day, they said, we're closing school because it's too cold. And I said, that's a thing?
Mm-hmm.
I guess,
Mm-hmm.
like,
Mm-hmm.
it got cold in Boise. It went below zero, but it never was negative 40
Yeah.
Fahrenheit. And that was too cold because kids would get frostbite standing outside waiting for the bus. So anyway,
Yep.
okay. So it's kind of cold in Detroit, but in December, it's like you just said, it's not as cold as February. So
Right.
it's about 1 degree. Cool. Do you know where Siberia is? Oh, wait, I'm sorry. Before we go to Siberia, we got to graph that Detroit, Michigan point. So
Okay.
where's the point 28.1? 28 comma 1
Still in the first quadrant.
and over 28, but only
Up one.
up 1. Cool.
Yep.
If you had listened to, no, maybe I don't want to do that quite yet. Yeah, I think I do. Hey, Kim, where would a point be if the place had the same average temperature in July and in December? Where would that point be?
Um, would it be at the point of origin?
Well, then that would be if it had a zero,
Zero. Oh,
zero,
oh, oh! All the temperatures. It's going to be. Doesn't matter what the temperature is. It's always going to be
the same.
the same. It's going to be on the y equals x line.
Yeah, like we're kind of last week where we talked about where the
Yeah.
guesses equal the average or the y's equal the x's. In this case, it's where the July temperature equals the December temperature.
Yeah.
We'd kind of have this 45-degree line that's kind of where they would all be the same.
Yep.
So the reason I brought that up is, so if that's kind of where that's the line, July equals December
Mm-hmm.
temperatures, where did Austin and Detroit fall? They're both in the first quadrant. How do they compare to that July equal December temperature line?
They're both under the line.
They're both under the line
Mm-hmm.
because
Because it's warmer in the summer.
in July. It's warmer in
Mm-hmm.
July than it is in December. So we go over farther before we go up a little bit, right?
Mm-hmm.
Over
Yep.
farther because it's warm. Only go up a little because it's not as warm in December.
Yep.
I podcast listeners, you're going to have to tell us as we're describing that, you can't see it. So like, let us know if you're like, we did not follow what you might want to get a pen and pencil and pen for me, pencil for Kim, and kind of like sketch out what we're talking about so you can kind of visualize. But it's kind of noteworthy that now maybe someone's saying, Pam, all of the points are going to be under that line because it's always warmer in July than it is in December, right? Are they all going to be there? And we'll just maybe raise that question and then move on. Okay, Kim, how about Siberia? Where is Siberia? Any ideas?
It's like Russia.
Yeah. Yeah. And when I say Siberia, what comes to mind? Warm or cold?
Cold, 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 cold.
Cold, cold, cold. Okay, so the average July temperature in Siberia is actually 14 degrees Celsius. 14 degrees Celsius. And 14 degrees Celsius for those Fahrenheiters, that's about 57 degrees Fahrenheit. So in July, that's cool.
Yeah.
It's not. I don't know that that's really cold. That's
I'm
cool.
not going swimming then.
No, but it's not freezing, right? Like
Right.
I would have
Right.
Siberia. I guess I wondered if Siberia was cold all year long, but it's not. Like there are temperatures that are sort of normal-ish. So interesting. My brother actually did a mission for our church for 2 years in Siberia.
Oh
And
my gosh.
I know, right? And when he went, he took a ton of long underwear because it's Siberia. Well,
Yeah.
as soon as July came around, he was sending us messages, send me normal underwear. Like it was kind of
Yeah.
funny. I mean, it was kind of a joke. He could buy underwear, but yeah, it was, he didn't realize that it would be normal. Okay. More than you wanted to know about Siberia. Anyway, thanks Brad for letting me share your underwear story on the podcast. He had a great time for 2 years. So in December, how cold do you think it is, or what's the temperature in December? What's your guess, Kim?
-20.
So it's actually -14.
Oh, I almost said 14. Dang it.
But it's
Okay.
-14 Celsius.
Oh.
So any guesses what
Ooh, gosh.
-14
Oh no.
Celsius is for
-40.
Fahrenheit?
I'm gonna go 40. Oh wait. You said 5/9 or 9/5?
Well, it depends on which direction you're going.
Okay. I'm
Negative
gonna go
14.
-30.
So -14 Celsius is actually only 7 degrees Fahrenheit. Isn't that wild?
Oh,
So
okay.
it's so 7 degrees Fahrenheit is still cold, right? It's
Yeah.
just not below zero. It's definitely below freezing.
So it's 57 in July for me in Fahrenheit and
Uh-huh.
7 in huh.
Average temperature in December. So December. Now 7, I mean average, that means it's going below 7 to get an average of 7, right? Because it's an
Yeah, for
average. So
sure,
this is a
for
place
sure.
where we could talk about average. And it's in December, not February, but yeah, we've got,
Okay.
yep.
All right.
Okay. Okay. How about, so hang on. I gotta think for a second. So Siberia is interesting because it was 14 degrees. I'm staying in Celsius because it's going to make my graph work better. So it's 14 degrees in July and it's negative 14 degrees Celsius in December. Where's that point?
14, negative 14, is that what you said?
Yeah. Uh-huh.
That's in the fourth quadrant.
And that's for all of those who don't memorize the quadrants. That's in the right lower quadrant,
Uh-huh.
right?
Yep.
Lower
Yep.
right underneath the one that we were just messing with. So
Mm-hmm.
that's interesting. Like I don't know if anybody envisioned that we would have points that would be in the fourth quadrant in that other but Siberia, sure enough. And what does it mean to be in the fourth quadrant? Let's see. It means something about summer temperatures. Uh,
It's still warmer in July than it is in December.
yeah. So warmer in July than December. And what can you
Yep.
say about temperatures in December if I'm in the fourth quadrant?
They're negative.
They're negative. So they're below freezing for sure.
Yeah. Yep.
Super cool. Okay. I'm just making a note on my graph. Okay. So how about Santiago, Argentina? Any ideas?
Oh, warm.
That feels
Negative.
warm to you?
Yeah.
Okay. Feels warm to you. Well, in July, the average temperature in Santiago, Chile is actually 13 degrees. Not so warm.
Wait, 13 degrees Fahrenheit?
Celsius, sorry.
Oh,
So
well,
13 degrees Celsius is 55 degrees Fahrenheit.
we were just talking Siberia, so it's warmer. That's in July though?
Oh, warmer. Yeah, that's in July. That's interesting, huh?
Holy cow. Okay, yeah, I would have said it was warmer than that. Wow. All
Yeah.
right.
Yeah. So then I wonder what you think when I tell you that December temperatures in Argentina are 27 degrees Celsius. So 27
Mm.
degrees Celsius is 80
Oh,
degrees.
dang it. I didn't think about that.
what just what
Shoot.
just what just happened? What just happened?
I forgot about the opposite seasons.
What do you mean opposite seasons?
Yeah, July is more like winter time and December is more summertime.
Because where's Santiago, Chile?
Yeah, it's below the equator.
Bam. Or sorry, Santiago. I said Chile, but I meant Argentina this whole time. Though both of them are below the equator.
Yeah.
So below the equator, the seasons are reversed.
Yeah.
Okay, so where does that put the points for places below the equator that kind of have typical-ish temperatures? They're kind of 80 when in their summer and 50 in their winter, which is where the what we just did. Those are the Fahrenheit. So it's I'll go
Tell me those
backwards.
numbers again.
Well, let me put them in Celsius because that's what I want you
Okay.
to graph.
Yeah.
So 27 was in their summer, which is the December temperature, and 13 in their winter. So it's the ordered pair 13, comma 27. Does that make sense? Let me just say that again. The 13 is the temperature in July, but that's their winter. And the 27 is the temperature in December, but that's their summer. So 13, 27, where's that point?
It's going to be above the line.
And it's still in the first quadrant, right? But
Yep.
now it's
Yep.
above the line. Now
Yep.
it's above the line. Yeah.
Yep.
Okay, cool.
So above the line is going to be colder in July than December.
And where are places like that in the world?
Below the equator.
So that's kind of
Kim.
interesting. Yeah.
Yeah.
So no stress, no stress. So there can be places that we can say, hey, they're going to kind of hang in the first quadrant below that equal temperature line if they're in the northern hemisphere, and they're going to be above that equal temperature line if they're in the southern hemisphere.
Yeah.
And look at us bringing in geography into math. Woo! Nice. Okay, Kim, I think this one might be one that you know better than anybody. Nome, Alaska. Now, I know that you didn't live in Nome, Alaska, but I do believe you lived somewhere in Alaska for a hot minute.
In
Yeah?
Anchorage. Yep.
In Anchorage. There you go. So, how cold do you think it is in July in Nome?
I'm gonna go like 70. No, maybe like 70. I'm gonna go 70.
So, Fahrenheit. So, it's actually 50
Oh, sorry.
Fahrenheit. It's actually 50
Oh,
Fahrenheit.
okay.
So, a little colder than you thought it was.
Yeah.
That's about 10 degrees Celsius. That's about 10
Okay.
degrees Celsius. And then what are you thinking in the winter? Is it cold in the winter in Nome, Alaska?
Oh yeah. Yeah.
I would think it might be.
Yeah.
How cold?
I'm gonna go with Oh, an average. People in Nome are listening and they're like, Kim.
I mean, you were young. You were super young,
I
right?
was young, yeah.
Yeah.
I'm going to say 20
You think
Fahrenheit.
it might be 20 degrees. So below freezing, but not super below freezing.
Yeah.
So it's actually negative 14 Celsius, which is about 7 degrees Fahrenheit.
Okay.
So yeah, below freezing, a little colder than you thought, below freezing,
I
but
don't remember that so much. Okay, so Anchorage is probably warmer than Nome.
oh, that could be, sure. Okay, so the
I'm
Celsius.
worse at this than you are at ages, for sure.
I mean, if you would have been asking me these questions, I'm geography might be the only thing I'm worse than guessing
Oh.
celebrity ages might be geography. Okay,
Okay.
so I could tell stories about my husband is a geographer. That's like part of
Yeah.
what he does. He loves geography, so I'm abysmal. And we work well together. It's good. Okay, so the values in Celsius for Alaska, for Nome, Alaska, were 10 and 14. So where's the point 10, 14?
Also above the line.
Also
Just
above the line. So that's
yeah.
interesting.
Yep.
No, wait. Above the line. I should have said 10, negative 14. That would help.
Oh, okay. Then yeah, it's
Sorry.
gonna be the fourth quadrant.
So
I'll
that
trim.
negative kind of made a difference there.
Yep. Yep.
Okay. 10. So that's in the fourth quadrant. It's below the x-axis. And so
hmm
what is that? What could we start generalizing about points below the x-axis? Siberia was there. Nome, Alaska was there. Is there any
they're super cold.
super cold? And
Yep.
also northern hemisphere.
hmm
Northern hemisphere, super cold. Cool. So I wonder right now if anybody's starting to think about other quadrants. Like I wonder if we've got points right now that we focused on that were in the first quadrant and we start to make a differentiation between whether they were in the northern hemisphere or the southern hemisphere, where the seasons were flipped. We've also got some points still in the northern hemisphere, but they're in the fourth quadrant because they're super cold in the winter. I wonder if anybody's starting to think about points that could be in the second quadrant or the third quadrant. Like, where are places like that in the world? That might be an interesting thing to think about. All right, here's your next location, Kim. The Greenland ice cap. Where's Greenland?
Ugh. Super north and freezing all the time. I can't
Okay.
imagine that it gets warm there at all.
Well, I'll tell you, in July, the temperature is negative 11 Celsius. And in December, the temperature is ready, negative 47
Ouch.
Celsius. So that's the
Yeah.
coldest one we've said so far. Just for those of you who are Fahrenheit bound, negative 47 is negative 52 Fahrenheit.
Good gravy.
That's really cold. That
Really
is
cold.
super, 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 super cold. Where's that point, Kim, if you were to graph that one?
That's in the third quadrant for
Negative
sure.
11, negative 47. So somewhere that is cold all year long. And
hmm
in fact, not just cold, but below freezing all year long. The Greenland ice cap, right? It was negative in July, negative 11, negative 47. Didn't get above freezing, at least in those two months,
hmm
is in the third quadrant. All right, so we found one in the third quadrant. Bam! I don't know if it's noteworthy that it's in the northern hemisphere. I don't know. How about Antarctica?
Like horribly cold. Don't
Do you
go
think it's
there.
do you think it's colder than Greenland? I'm kind of curious.
I think it depends when of the year you're talking about.
Ah, say more about that.
So I think it's colder than Greenland in the summer. Well, what we would call summer in July. I'm going to go with the month. I think it's colder in Antarctica in July, but I think it's warmer in December
And
because
why are
one's in the
you?
northern hemisphere and one's in the southern
There you
hemisphere.
go. Okay, so we flip the hemispheres. So you're
Yeah.
flipping the two, and sure enough,
So then that's
Antarctica
in
is
second.
well, maybe Antarctica is negative 57 Celsius in July and
Uh-huh.
negative 18 in December.
Oh no, it's still in the third quadrant.
So I'll just say those temperatures again: negative 57 in July and negative 18 in December. So super super cold. In fact, that is the coldest temperature we've had so far. Negative
Yeah.
57 Celsius and negative 57 Celsius. Just for those of you who are curious, is negative 70 Fahrenheit. Woo! Super cold. So Antarctica in July is really 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 cold, but in December it's still really cold, right? Like what would a place have to? Because you were thinking third or second quadrant. Kim, I'm stretching you here, I think, but what would have to happen to a location for it to live in the second quadrant? in the upper left-hand quadrant. Upper left-hand quadrant is the second quadrant. What would have to be true of the numbers? Or maybe the...
Well, I don't even know what I put on the X and Y, to be perfectly honest with you. I'm
So X
working
is
on a tiny
July.
Post-it note. So X is okay.
X
That
is
probably would
July
have been
temperatures.
helpful.
X is
Okay.
average July temperatures, and
So in
Y is
July,
average
it would have to
December.
be negative, and in December, it would have to be positive.
Okay, let's keep talking. So if July is negative, that means it's
So it's
cold
cold
in
in
July,
July, and it's warm in December. So it's
warm
got
in
to be in the
December.
southern hemisphere.
Yeah, because the temperatures or the seasons are flipped. Yeah.
Well,
So
flip for
Kim,
us.
I can't flip for us. Thank you. Yeah, ethnocentric there. Kim, I have to tell you, I spent a long time. Now, I didn't do this recently. I did this quite a while ago when I was gathering this data, but it took me quite a while to find anywhere in the world where it would be cold enough in July to be negative and warm enough in December to be positive. And the only place I found was a place called Butler's Gorge, Australia. Woo!
Oh.
Hey, Aussies, there we go. So, and it was so close. If we rounded up, it wouldn't work. So I'm not going to round. So negative 0.4 degrees Celsius in July, negative 0.4. So we're just back from the zero.
Yep.
And then 5 degrees Celsius in December. So just above. And we are barely in the second quadrant. It was the only place I could find. Now, hey, so podcast listeners, anybody want a free t-shirt? Somebody find me another place that's in the second quadrant. First person to ping me. Where do I want you to ping me? Ping me.
They can
Facebook.
email me.
Let's do social media.
Okay.
Yeah. So Facebook, Instagram, or Twitter. The first one that we'll look at the date, the timestamp.
Okay.
First, anybody that can find a second quadrant location other than Butler's Gorge, Australia. We'll send you a Math is Forgettable t-shirt. That'll be kind of fun. All right. So Kim, I think this is a cool task. To get kids doing a lot of things. But let me tell you we're kind of running a little long here, so maybe I'll do this a little short. But we just described locations in the world that would be in the first quadrant, and not only in the first quadrant, but that would be above and below kind of an equal temperature line, that Y equals X line. We also described places in the world that could be in the second, third, and fourth quadrant. One thing we didn't do, but algebra teachers, this could be fun, is describe between the I can do it. I could read my own writing. Was it Australia and Greenland that were in the third quadrant? I think so. It was Australia. Yeah, Australia and Greenland. Yeah.
Mm-hmm.
Between Australia and Greenland in the third quadrant, which of those were above that equal temperature line? And what does that mean for their location? So there's something going on in the third quadrant, just like there was in the first quadrant with that equal temperature line, because that equal temperature line goes to the third quadrant as well, right? Like Y equals X is not just in the first quadrant, it's also in the third quadrant. So there's something going on there. And then could we get a little general and say, hey, what was true about, and now I wish you could see me write, but what was true about all of the July, and I'm writing the word July, temperatures that were greater than, and I'm writing the greater than symbol, the December temperatures? Or in other words, what was true when all of the X's were greater than the Y's? And we're starting to graph inequalities. An inequality where Y is less than X or Y is greater than X. So I've literally written an inequality. And when we could talk about locations in the world where it's true, what's true with temperatures when all those X's are greater than Y's or the X's are less than the Y's, and we could actually shade in half planes, making sense of that inequality with the context, with locations and geography. Bam!
Yeah.
And I'm a little particularly proud. So I made up this task based on Gail Burrell's really super cool age guessing task, and I kind of like it. I think there's some really nice higher math that we can get to that is actually figure outable.
Yeah. Well, this is super fun for me. I love when we get an opportunity to have conversations about stuff that may have been I almost said shoved at me, but I'm going to, shoved at me with not a lot of meaning and not a lot of context. And I can't wait to do this one with my kids too. Woo! Everyone is telling you, listeners, that higher math is rote memorizable, and we are telling you that it's all figure outable.
Y'all, so thank you for tuning in and teaching more and more real math. To find out more about the Math is Figure Outable movement, visit mathisfigureoutable.com. Let's keep spreading the word that math is figure outable. Thank you for listening and making math more figure-outable.
To learn even more, make sure you register for our free challenge at mathisfigureoutable.com/challenge. You are not going to want to miss the evenings of May 15th through 17th, starting at 7 p.m. Central.
Math teaching, go register now. That's mathisfigureoutable.com/challenge. Join us to make math more and more figure-outable. And if you can't join live, register and we'll send you access to the recordings. We'll see you there.